We recording? Yeah, we are. Ladies and gentlemen, welcome. We've got a lab coming up on Wednesday of this week. And so we're going to try something a little different and use a video to get you prepped, and then you'll have a resource to go back to in case you get stuck in the lab. The lab will be in our regular lab manual, and it's going to be lab 11B, the specific heat of a metal. We've been talking about this and using equipment in a different way that will help you out with this lab. So I think we're primed and ready to go to do this lab and be successful. I'm going to show you the equipment real quick and the basic idea of the lab so that on the day of you'll be able to work quickly and safely and get good results. There are a couple fancy words for some relatively simple things. These, as we know, are styrofoam cups. We used these before. The difference in this lab is you're going to create what's called a calorimeter, which is just two styrofoam cups placed one inside the other. That's a real basic form. This is just going to give you an extra layer of insulation so that heat will not easily be able to get in or escape from anything that's inside the cup. Okay? You'll use another styrofoam cup to transfer some hot water to a piece of metal, actually. So anyway, before I get too lost in my words, here's the basic idea. The lab will have you place some room temperature water into the calorimeter. It will have you actually measure it, so make sure that you use a graduated cylinder so that you know exactly how much water goes in. That helps you figure out what the mass of the water is, because remember, 1 gram of water is equal to 1 milliliter of water. So if I put 150 milliliters in here, we're going to consider it to be 150 grams as well. Okay? Now, that being said, you'll use some really, really hot water, which this is not, but let's pretend that it is, and place it into the other styrofoam cup that is not the calorimeter, and you'll be placing, to start off, a copper block into that water and allow it time to heat up. If we put that block in that water, remember, given enough time, the block and the water in here will reach the same temperature. Okay? We'll be using our temperature sensors as well to measure what the temperature is in the calorimeter before we get started. And once given enough time, we can use the tongs and remove the metal block from the very hot water and very carefully transfer it over, without getting much water with it, over to the calorimeter. Okay? Now I know you folks know what's going to happen here. You've seen it before. The very hot metal that is in the calorimeter now will transfer some of its energy over to the room temperature water. And the temperature of that water is going to heat up. How much it heats up is what we're really interested in. We're going to be dealing with kind of a complex equation in this lab, where we're going to take a look at the heat energy that's transferred to the water from that metal. So this is the basic setup. This is the basic idea. What we want to know is, how much does the water in the calorimeter heat up? If it starts off at room temperature, if it starts off somewhere around 25 degrees Celsius, how high does it go when we put that hot metal in there? Okay? From last week's lab, you know that the temperature of the metal is going to change a lot, and the temperature of the water is only going to change a little bit. But from that change, we can determine how much energy that block transferred into the water. That's real important. Okay? That's when we know what copper is. The second part of this lab, you'll take a block of metal, and we won't identify it. We won't tell you what it is. But you'll run the same basic experiment, where you'll place this block into very hot water and let its temperature rise. And once it rises, you'll then take that that hot metal, and you'll transfer this metal block from the cup over into, if I can get it out, you'll transfer it over into this cup again. And you'll see how much energy transfers from that block into the water. And we're going to use kind of a complex equation to figure out what's the specific heat of that metal. That specific heat of the metal is something that can be used to identify it. So we're going to figure out what it is based on how much it raises the temperature of the water in our calorimeter. Okay? Now, before you're going to be able to do this lab, you're going to have to pass a little pre-lab quiz. I'm going to give you the answers to it right now, though, so if you watch the video, you should be fine. Okay? The first thing you need to know is that the first metal that we're going to work with is copper. Make sure you know that this first block that we'll be dealing with is made out of copper. All right? We used aluminum last week, copper this week. Then I want you to know the lab says that you'll be testing 2 unknowns. We will only have you test 1 unknown. So you can demonstrate that you watched this video by knowing that we're only testing 1 unknown metal. Okay? Please know that when we place the 2 styrofoam cups together like this is known as a calorimeter. All right? And please also remember that for 1 milliliter of water, we're going to say that it equals 1 gram of water. So if I tell you that I have 10 milliliters of water and ask you what the mass is of that water, you don't need a scale today. You just say 10 milliliters is equal to 10 grams. All right? Provided you pass that quiz, then we will have you go ahead and start the lab, and this lab again will be on Wednesday. We'll have you break down the lab on Tuesday, read through it and flip through it and watch this video, and you'll need to watch the video as many times as you need to pass that pre-lab quiz. All right? Thank you very much.